Alright guys, so we're going to start into our last unit today with the second fundamental theorem of calculus. Kind of warned you this was coming, and here it is. So what we're going to begin with is just our bell work, and that is of course to write the average value of a function. So pause it if you need to do it, otherwise go ahead and check. So we should just be doing 1 over our 2 bounds subtracted of the integral of those same bounds of fx dx. Our bounds are a to b, so we put them that way. I didn't specify that a was less than b, so technically speaking, you also could have written it this way. Because I didn't specify, usually when you get a question like this, it'll specify that a is less than b or whatever. Now, if it's written in interval notation, technically it should be written that way, so this would be the better answer for sure. And we just also usually assume that a letter earlier in the alphabet is smaller. Alright, as you can probably tell from my voice, I'm going to go ahead and take a moment to just say I am really sick, you guys, so bear with me. Hopefully you can hear me, and hopefully I don't make too many mistakes from my head swimming from illness here. Alright, so the next thing we're going to do is we have this function here, which is equal to the integral from 1 to x of ft dt. F of x and f prime of x are written in terms of x. So, if I have f of t and I integrate it, that's where we've been using that capital before. So here I'm going to try to find f of x, and I know that it is equal to the integral from 1 to x of f of t dt. Now, if I'm doing that, they've given me f of t here, so I'm going to go ahead and I'm going to integrate it. And so this means that it's going to be equal to 2t squared before t squared divided by 2, and those 2's cancel, minus t cubed over 3, and we're going to evaluate that from x to 1. Now when I put x in, don't be alarmed that it's not a number, it still just goes in there, same as always, so 2x squared minus x cubed over 3, and then we're going to put in 1, so it's just going to be 2 minus a third. This, of course, then can be simplified further because this is just a number, and so this would be 2x squared minus x cubed over 3, minus this would be the same as 6 thirds, so when we subtract 1, we get 5 thirds, like so. Okay, now it asked us also to find f prime. So that's the next thing I'm going to do here is I'm going to find f prime of x now and just take the derivative. So this becomes 4x minus x squared because the 3 comes down and cancels with the third, and the 5 thirds goes away. Alright, so then on this side we're doing the same kind of thing, except this time we're using a trig function. So f of x is going to be the integral from 1 to x of cosine of t dt. The integral of cosine is just sine, so it'll be sine of t evaluated from x to 1, technically plus c as well, but because we're evaluating it, it's going to go away here. So this will be sine of x minus sine of 1. This doesn't work out on the unit circle, so we're just going to leave it like that. And that would be my f of x. Now f prime of x is pretty easy. If we look here, it's just going to take us right back to cosine of x. And so if you look here at those 2 derivatives, what you should notice is that you have the original function. All we've really done is change our t to an x. So 4t minus t squared became 4x minus x squared, and cosine of t became cos x. So in essence, that's what we're doing here. Alright, well what about if we do things a little bit differently, and this time we're integrating from 1 to x squared? Well, the process is going to be the same, so f of x is going to be equal to t cubed, the integral from 1 to x squared of t cubed dt, apologies. And that's going to be equal to t to the power of 4 over 4 evaluated from x squared to 1. Well, x squared to the power of 4 is simply going to be x to the power of 8 over 4 minus 1/4. And so that would be my f of x. And my f prime of x here is going to be 2x to the power of 7. And notice this time it did not get us right back, which is to be expected because this time we integrated to x squared instead of just x. Let's take a look at this next one here. So f of x is the integral from 1 to x squared of 6t to the 1/2 dt. If we integrate that, we're going to get t to the 3/2. It's technically 6. Well, let's write it out the long way. Let's not do it in our heads this time. 6t to the 3/2 times 2/3. Because if we divide by 3/2, that's the same as multiplying by the reciprocal. And that's going to be evaluated from x squared to 1. First, let's go ahead and simplify this a little bit here. So this is going to be 4t to the 3/2. Evaluated from x squared to 1. And so that will just, that is going to be 4x squared to the 3/2, which is really just x cubed. We multiply those, minus 4, and that would be our f of x here. And then our last step was to take that f prime. So the f prime of x is going to be equal to 12x squared. Okay, and this brings us to what our actual second fundamental theorem of calculus is here. Actually, no, this is probably easier for me to write. So this states that if f of x is equal to the integral from a to a function of f of t dt, where a is a constant, so a number, then this tells us that f prime of x is going to be equal to f of g of x times g prime of x. And that should strike you as being what looks like a chain rule. And so that is effectively what we are doing, because we are putting this g of x inside the f of t. And so that's how we end up getting that chain rules, because that's really what it is. Okay. This page is wrong here. I believe it's page 5. What is it? These ones are from back here, so that's page, I don't even know. From the previous page. It's because I've changed the number. I used to have one big packet. Okay, so f prime from here was 4x minus x squared. And if I apply the second fundamental theorem of calculus, then f prime of x is going to be equal to 4, and I'm just going to put that x in, so 4x minus x squared, multiplied by the derivative of that function that's up here in the integral, so in this case that's 1, and I would get 4x minus x squared. Now that one's a pretty easy one, so it obviously works out. What about if we do something with trig, or then when we get into the x squares? Alright, so this one was just cosine of x, and if we apply the second fundamental theorem here instead, then that's going to be cosine of x times the derivative of this function here, which is again 1, and so it's just cosine of x. Again, not that hard. What about when that function g of x is something a little bit more complicated, like in the next two, where it is x squared? So our derivative for this one was 2x to the power of 7. Let's see if we can recreate that using the second fundamental theorem. So here, we're going to plug it in, so x squared cubed times the derivative of this function here, which is 2x. And when I put all that together, this is x to the power of 6 times x will be x to the power of 7, and then 1 times 2 gives me that 2, and so I do get the same thing. Now this one was 12x squared. Let's see if once again, I'm sure by now you're figuring out we should, but let's get it and we can check our work here. So I'm just going to plug that in first, so this is x squared square rooted, okay, times the derivative, which is again 2x. Now this is nice because the square root of x squared is just x, And so really, this is 6x times 2x, which once again gives us that 12x squared like we were expecting. So, we can see that that fundamental theorem does indeed appear to work, and it lets us find this without having to first integrate and then differentiate. So let's try applying that then to a couple more equations that are a little bit different here. So now we're going from -2 to 2x. So we can figure out that f prime of x here, sorry, and it does, it's just on the other page, but it says find the derivative, so that's why we're doing this. It's going to be equal to 2 minus 2x squared, because the first thing we do is we just plug it in like so. And then we multiply by the derivative of that function in the integral, so in this case 2. And the really only thing I can do here is rewrite that with that 2 in front, which just makes things a little bit more simple. And I can simplify this 2x all squared to be 4x squared, which is a good idea, because otherwise, inevitably, one of you will forget and write 2x squared instead of 4x squared, because it is squaring both terms here, both values. All right, so let's try this one here. But if you look, we've got a bit of a problem, because remember we always said that the smaller one should be on the bottom, and if x is squared, it will never be negative. So it needs to be pushed to the top. So our g of x first needs to be rewritten as being the integral from -3 to x squared of e cosine of t dt. But remember, when we switch them, we need to put a negative in front like so. So I'm going to switch to lowercase because I find the capital G's, for me at least, look like 6's, and I'm sure it'll annoy you all. So g prime of x here is going to be equal to e times the cosine of x squared times the derivative, which is 2x. And there isn't really anything I can do there other than to rewrite it, so I will write 2x e to the cosine of x squared. Alright, one last one here. This one is written properly, so we don't need to do any manipulations. We can just go straight to solving for the derivative. And so this one is going to be cosine of x all squared times the derivative of cosine, which is negative sine. And as I always tell you guys, move that negative to the front so you don't make a mistake. So h prime of x is going to be equal to negative sine x times cos squared of x. Awesome. All right. Let's try applying some of these to more, rather than just an equation. Let's apply it to a bit more here, where we've got a graph as well. So we have the graph over here of g of t, and f is going to be a function defined by the integral from -4 to x g t dt. So the first thing we're going to do is we're going to find the value of 0. So in this case, we don't actually need to do what we were doing before. We're just going to switch this and find f of 0, which is going to be the integral from -4 to ultimately 0, because 2 times 0 is 0, of gt dt. Now I can't write it that way, so the next thing I'm going to do is it is, right? I was thinking it was in the wrong order, but it is smaller to bigger. And so then we can just work out, well, what that actually is, right? So we go look over here, and if we're going from -4 here all the way over to 0, the first thing we can notice is probably that this part is going to cancel out, so we can ignore it. So all we really need to do is find these two shapes, our rectangle and our quarter circle. So our rectangle is just 2 times 1. And then that quarter circle is going to be pi r is 2, so pi 2 squared all over 4, which simplifies to just be 2 plus pi as our final answer. Alright, well, what about if we are finding it when it is 2? Okay. So now we're going to find f of 2, which first thing we should do is just kind of check what does that actually mean. So 2 times 2, this is from -4 to 4 of gt dt. And you'll notice here that from -4 all the way to 4 is the entire thing, and this is an even function, right? If it is even, then we know that it's just going to be 2 times the integral from -4 to 0. So we can just say that it's 2 times 2 plus pi to give us 4 plus 2 pi as that answer. Okay, so knowing those odds and evens can help us just kind of figure out like some shortcuts, basically. Now we're going to put that second fundamental theorem into practice here, because now we're finding the derivative. So f prime of x, first of all, is just going to be g, right, g of t. So we're going to replace that to be g of, and it is 2x that went into it times 2. So f prime of 1 then can be g of 2 times 2. And if we're looking for what g of 2, so let's look up here so we can make sense of this. This is the graph of g of t, right? So now we want to find g of 2. So here we're at this point right here, which is just 1. And so this is going to literally become 1 times 2, or just 2. So we're able to take some shortcuts when we're doing that derivative there. So similarly down here, we can do the same sort of thing. If we're looking for the derivative, well, that means that it's going to be equal to g of 2x times 2. Let's put that 2 in front this time. So then we can go ahead and plug in our value here, which is going to be 2 times g of 2 times negative 2 is negative 4. And then I just need to go and look at what exactly g of negative 4 is. At negative 4, it is right here at negative 1. So that's going to give me that value of negative 1. And so I get that the answer should be negative 2 when I simplify it. All right, what about if we're doing the second derivative? Well, let's start by just finding that first derivative, okay, because we know how to do that at this point. We know that it's 2g of, 2 of x, okay? So then let's go ahead and let's find g double prime now. So the 2's still there. We're going to have to do a chain rule. So this is g prime of 2x times the inside, which is 2. So in other words, it's going to be 4g prime of 2x. So then we can find f double prime of 2 now, which is going to be 4g prime of 4. So if we go and look at 4 here, right here, the derivative doesn't exist because it's an endpoint. So therefore, we can say that this entire thing does not exist because g of 4 is an endpoint. Or you could say sharp corner, or can't take the derivative. However you want to say that is fine. Okay. So then, we've got another one here, another piecewise function. A little bit more complicated. This one's f of t, doesn't matter what we call it. It's got 3 line segments here and then a semicircle, and we want to look at the fact that g of x is actually the integral from negative 1 to x of f t dt. So the first thing that we should be doing here is finding g of 6. So that means that we can just literally plug it in here. So this is going to be the integral from negative 1 to negative 6 of f of t dt. But, oops, it can't be written that way, so we're going to switch it, put a negative in front, and change it to be negative 6 to negative 1, because it always needs to be written with the smaller one at the bottom. So then from there, we're going to go from negative 6 up to negative 1. And so here, this is a positive shape there. Keep in mind there is a negative in front of everything. And that one's going to be a triangle, so it's going to be 1/2 times 4 times 2, or just 2 times 2, so 4. And then this part here, this is negative, so we're going to be subtracting it. And that is simply going to be a trapezoid. So the width of 2 times the average of our 2 lengths, which is going to be 1, 2, 3, and 2. So 5 when we put them together, which of course cancels those out. And so we just get that this is negative 4 minus 5, which is ultimately positive 1. All right, well, we're going to do the same kind of thing here, except that this time we're going to find it at 6. So g of 6. Okay, this time I don't need to rewrite it. It's going properly from negative 1 to 6 here, you can see, of f of t dt. And so this time all we need to do is actually go and work that out. So from negative 1 to here is just a trapezoid again. So we've got 2 times 1/2 times our 2 lengths, which is 5 and 3, so 8. Plus, here we're doing half of the circle, semicircle, and the radius is 2, so that's going to be pi 2 squared over 2. sorry, I lied. We're only going to 6 here, aren't we? So that's not actually the entire thing. It's only a quarter of the circle, so it should be over 4. Okay. So here the 2.5 cancel. And so I am just going to get here that this is going to be 8. But I didn't think about this. This is in the bottom here, right? So this actually should have been negative. So this should be negative 8 plus 4 over 4 goes away. It just becomes 1. So it should be this. Or if you prefer, pi minus 8. What I missed there was that negative because it's below the x-axis. So even though this was looking like it was going to be positive 8, if it's below, it needs to be made negative. Alright, so now we're going to use that second fundamental theorem again. So g prime of 6 is going to simply be f of 6 times the derivative of what's inside. And up here, since it's just x, it's just going to be times 1. So it basically doesn't even matter. So now I just need to go find f of 6. At 6, it's 2. And so my answer is just 2. Okay, don't overcomplicate it, guys. So once again here, g prime of 2 is going to be equal to just f of 2 times 1. And f of 2, if we go look, is negative 2. So the answer to this one is simply going to be negative 2. Okay, if you need to write it out with the g prime of x first, by all means go ahead. But when they're pretty easy like this because we're integrating to an x, I usually don't bother because it means that the derivative is literally going away because the derivative of x is 1. Alright, so this time we are going to have to because we're doing the second derivative. So g prime of x, we're going to start there. And we know that that's just f of x times 1. And then g double prime of x is going to be equal to simply f prime of x. So in other words, we're looking for the slope. So g prime of 2 is equal to f prime of 2, meaning we just want to know what the slope is. So at 2, we look here, and we've got this sharp corner where we can draw a whole bunch of different tangent lines. And so remember, that means there is no derivative. So here, we can actually say does not exist because f of 2 has a sharp or cusp corner and so has no derivative. Actually, maybe a better way to say that is it has an infinite number of derivatives, but the point is the derivative doesn't exist. Now over here, we already figured it out, so we don't need to redo all that. We can just say d double prime of negative 4 because we know that it's just f prime. So this is just f prime of negative 4 now. So this means I'm looking for the slope at negative 4, and at negative 4, it's this nice line here, so I can find that slope. That slope is going to go from, let's see, 4 to negative 2 is a rise of negative 6 over a run of 3. So this is going to be negative 6 over 3, or just negative 2. Reason for our answer, I guess, would simply be that that's the slope. That is the slope at f of negative 4. I'm sure I know 4 like that. Alright, so I think we have just one more here. So let's take a look at that one. So here we've just got another fancy function. We've got a quarter of a circle, a quarter of a bigger circle, and then a big triangle. Alright, so this function is defined from negative 4 to negative 3. Graph consists of 2 quarter circles and a line segment, like I just said. Triangles when we start putting it into integration. And we know that g of x is equal to half of x squared plus the integral from 0 to x of f t, where this here is f of t. So, in order to find our value of g of 3, first thing we're going to do is just kind of plug it in and see if we need to do what we need to do. So this is 1/2 of 3 squared plus the integral from 0 to 3 of f of t dt. So this part here is pretty easy. That just becomes 9/2. And this part we need to go and calculate, right? We need to go find the integral from 0 to 3. So here from 0 to 3, what you'll notice is we can't call it an odd function, but it has an odd function principle in the sense that from 0 to 1/2, it's positive with that triangle that has a height of 3, a width, a base of 1.5, sorry. And then here it's negative with that same triangle base of 1.5 and a height of -3. So like I said, they're going to cancel out. So it's 0, and our answer here is just going to be 9/2. If you need to actually work that out to prove that, go ahead, guys. But I have no problem, and neither will the College Board, with you looking at it and saying, those are the same shape, they're going to cancel. You should probably put a note on it, but it's not always even necessary, to be honest. All right, so g of -4, we're going to same thing, just plug that in to begin with. So 1/2 of -4 squared. Make sure you put the brackets around because the negative is squared here. All right, and then the integral from 0 to -4 of f t dt. Now, hopefully you're immediately seeing this is backwards, so we're going to have to flip it. But we can do it at the same time as simplifying this. -4 squared is 16, over 2 is 8. So this will be 8 minus, because we have to put a negative in front, the integral from our reversed bounds of f of t dt. And so now we need to just simply figure out what that is from -4 to 0. So we're doing these two circles. So this part of the circle is negative and has a radius of 1. This part of the circle is positive and has a radius of 3, and in both cases they're divided by 4. So this first one here is going to be pi r squared, which is just 1, over 4, and it's negative. So pi over 4 is negative. And then the other one has the 3, so this one's going to be pi 3 squared, and it's only a quarter of the circle. So I get 8 minus negative, which is going to be plus pi over 4, minus, and this is 9/4, so 9 pi over 4. And then, of course, I can combine those two to just give me 8 plus 8 pi over 4, which is just 2 pi. So that would be my final answer there. All right, and then last thing here, let's use that second fundamental theorem here. So now to find g prime of 3, let's start by doing g prime of x for you. So we had 1/2 x squared, that just becomes x, plus f of x times 1, because, again, this part of the function is just x, and when we take the derivative, that's just 1. So we just replace the variable there. So now we can go ahead and find g prime of 3, which is going to be 3 plus f of 3. So we just go look at 3 here, and at 3, it's -3. So we're going to get 3 plus -3, and so g prime of 3 is just 0. Now to find the second derivative, we take that first derivative that we already had, and we're simply going to differentiate it. So the second derivative now is going to be 1 plus f prime of x. So now what that means is we're looking for the slope at whatever value. So g prime of 2 means it's 1 plus the slope at 2. So let's go up here. 2 is right here on this big line. Our line segment goes from 3 to -3, so that is a height of -6, and it goes 3 over. So this is going to be -6 over 3 again, or just 1 minus 2, or -1. So the second derivative at 2 is simply going to be -1. And that's it, guys. Then you can go ahead, you can work on those practice problems there. And hopefully I will see you guys next class if I can start to get my voice back and feel a little better. See you soon.